Today, Academic Daddy is going to be solving the assignment given to pharmacy students. So there you have it. It says a gas at 25 degrees C occupies 3.60 liter at a pressure of 1 atm. What will be its volume at a pressure of 2.50 atm? So the second question, the third question, the fourth, the fifth. This is a usual question every year. Now, I need you to understand solving number one. Anytime you're given temperature, especially when the temperature is 25 degrees, we still remember that this 25 degrees is the same temperature when we talk about solubility. Even when we are treating gases, when I told you that anytime you are solving for thermodynamics, that you consider entropy there to be at 25 degrees when it's not given, which is 298 Kelvin. Now, if you know this, you need to know that once you're given just one temperature and you're given every other parameters, because analyzing that question, I have this. You're given every other parameters. You need to understand that what this is saying is that this is at constant temperature. And at constant temperature, we have a law which is called Boyle's law. And Boyle's law states that at constant temperature, that uh, pressure and volume are inversely proportional. So if I know that, it simply means that inversely proportional, I can have this to now be P equals to K over V, which is the same as PV equals to K. So why I have it as P1 V1 and equals to P2 V2 is that's initials and the finals. So substituting to find V2, I'll now have that this is the same as P1 V1 all over P2 equals to V2. So substituting the values I have that P1 is 1, that is 1 atm, times V1 is 3.60 in liters, and P2 is 2.50 atm. So since everything is in atm and liter, I don't have to convert anything. So when I do this dividing, I'll now have that my V2 will be 1.44 liter. That's my V2. That's my V2. Now the second question says a gas occupies 12.3 liter at a pressure of 40 millimeter mercury. What is the volume when the pressure is increased to 60 millimeter mercury? If you watched my previous video, you know that at STP, millimeter mercury is 760. So if I want to convert 40 millimeter to atm, I can say 40 divided by 760. But since I have this in millimeter mercury and I have the second one in millimeter mercury, there's no reason converting. Please, the only contribution you make to us is subscribing to this channel. Anywhere you find yourself, try to be a contributor. Say, as I'm gaining, what am I contributing? And that is for you to subscribe to the channel, like the video. Thank you. So it says a gas occupies 12.3 liter, that is V1 equals to 12.3. V1 is 12.3 liter. Now, what about V2? Okay, at this V1 is operating at P1. It's having a pressure of 40 millimeter mercury. Now, they're asking us for the volume. That is V2, second volume. We can never have a situation where we have V3. So, know it. So, V2 is equals to unknown. We don't know it. Now, they say when the pressure is increased. So, P2 increase, change, state function. P2 is equals to 60 millimeter mercury. So looking at this, the only things we have is volume and pressure. That means it's the same thing as Boyle's law. P1 V1 equals to P2 V2. To find V2, make V2 subject of the formula by dividing both sides by the coefficient of V2. So that we have this. So substituting what we have that this is going to be 12.3 12.3 for the volume times P1 is 40 all over P2 P2 is 60. And when you do the punching, that is when you punch it, you have that V2 is equals to if you punch it very well. Wait, what are you saying? Are you kidding me? Yes, okay. So if you punch it very well, you have that so you have that this is the Sentinel saying 492 divided by 60, and this will give you 8.2 liters. So V2 at this junction will be 8.2 liters, so it says 8 liters. So there you have it. Now for question 3. Question 3 says convert 273 milliliter at 166 kilopascal to its new volume at standard pressure. Sometimes they can say standard temperature and pressure, STP, whichever way they put it. You just need to know that question 3. Looking at question 3, I have volume V1 in 273.15 milliliter. So I need to convert it to liter. So that is essentially saying 273.15 divided by 1000. So that I get 0.27315 liter for V1. Now they are telling us to find V2, its new volume. V2 is what we don't know. At standard pressure, standard pressure and temperature. Standard pressure, which is P2. P2 will be 760 millimeter mercury. I know that 760 millimeter mercury is equals to 1 atm. 1 atm, that is to convert millimeter mercury to atm. You simply do this 760 divided by 760. The millimeter mercury will cancel that, you have atm. So if I know this, I'll now check the things I have. I have V, and I was given kilopascal for P1. They said that this volume, this V1, is happening at 166 kilopascal. It's happening at 166 kilopascal. So you know that at STP, 101 a kilopascal is equals to 101.3 kilopascal. So if you convert it to atm, it simply means divided by 101.3. Then when you convert, you can multiply. So we are given kilopascal. So this is something as 101.3 kPa. So that when this and this cancel, I have just the atm remaining. So that this is something as 1.6387 atm. That is for P1, because this is happening at P1, then P2. Standard pressure is 760 millimeter mercury, which is equals to 1 atm. So using the formula, since I have just pressure and volume, you have P1 V1 equals to P2 V2. That is finding V2, the new volume now, or the same as P1 V1 all over P2 equals to V2. And this is the Sentinels. This is the Sentinels having 1 point, P1 is 1.6387 atm times V1 is V1 is 0.27315 liter all over P2 is 1 ATM. So when I punch this, so that's our final answer, 0.5, 0.45, or you say 0.5 liter. That is our V2. So for question 4, for the fourth question, let's move to the fourth question. Question 2 says a 250 milliliter balloon, and 250 milliliter is something as 0.25 balloon, contains 0.35 moles. So here we are not dealing with volume, they are giving us moles of nitrogen gas. That is our first mole, 0.35. Then if 0.45 moles of N2, that is another mole, the second amount of nitrogen gas was added, that is N2, was added to it, what will be the new volume of the balloon? So we've analyzed it. So whenever we are talking about volume and mole, you know that what we are talking about is Avogadro's law. Avogadro is everything amount of mole, not a number of particles. So if you know that, you need to know that he said that volume is directly proportional to amount of substance. So the more you add air to balloon, the more the balloon increase in volume, in its space and size. So that is V directly proportional to N. V equals to K N. So that's making K subject of the formula. So this is how we have it. So this is now initial and final. So if you know this, let's try to substitute the values we have. And substituting the values we have that this is 0.25 all over 0.35 equals to V2 all over 0.45. If you cross multiply, you now have that this is something as 0.25 times 0.45 all over 0.35, and this will give you 0.1125 all over 0.35. That is the same thing as saying, notice it, when you cross multiply, this will go to this, then this will go to this now have then we divide both sides by the coefficient of V2, which is this one now, 0.35. So now when you do it, you now have that this is 0.3214, which is approximately 0.3 liter. That is our V2. So that is it for number 4 question. Let's move to number 5. Number 5 and the last one. Number 5 said a 20 liter. Number 5, a 20 liter vessel. 20 liter vessel holds, that is volume of the liter, is not gas, so it's not V1, that is total volume. So it holds mole. So mole is represented as X. It holds 3 moles. So mole of nitrogen gas, it holds 3 moles. Then and 2 moles, mole of oxygen gas, 2 moles. This is it. This is what we are given. Now they're asking us what is the mole fraction of N2 and O2. So please, anytime they ask you mole fraction or just X, know that mole fraction is simply mole of a gas, of a particular gas. Let's say here mole of N2 all over total mole. So the mole fraction of N2 is the same as this is represent this X is representing mole fraction. Sorry. So that means this is the same as N2 here is 3. Should be all over total mole is 3. That of N2 and oxygen 3 plus 2, which is equals to 3 over 5. So mole fraction of O2 is equals to mole of O2 all over total mole equals to 2 over 3 plus 2 equals to 2 over 5. So that means that the mole of N2 3 over 5 is equals to 0.6. 2 over 5 is equals to 0.4. So anytime they ask you to find the second part, they say what if the total pressure PT is equals to 1000. Anytime they ask you to find total partial pressure, they say find the partial pressures of N2 and O2. It's either you use this formula PV equals to nRT, or you use partial pressure is equals to total pressure times this is times mole fraction, So these two formulas, anytime you are asked to find partial pressure, so any pressure you find here is the pressure of a particular gas, and this partial pressure is equals to total pressure times mole fraction. So in this case, since I have PT to be 1000, so the partial pressure of nitrogen will be equals to PT times its mole fraction. Then the partial pressure of oxygen gas will be equals to PT times its mole fraction. This is times, then this is the mole fraction. In fact, I could have used dots. So if you use that principle, we now have that this is PP of N2 will simply be equals to 1000 dots 0.6, which will give you 600. Then partial pressure of oxygen will be equals to 1000 times 0.4, which will give you 400. Now this is the partial pressure of oxygen. So this is the partial pressure of O2. So this is the partial pressure of N2. So now that you know this, you need to know that assuming they ask you to find total pressure PT, that means you are not doing Dalton's law of partial pressure, which says that the individual sum of the partial pressures of the gas gives you the total pressure, which is the same thing as saying 600 plus 400 PN2 plus PO2, and this will give you 1000, which you already have. So there you have it. These are the 5 questions with the answers. So I hope you subscribe, like, and share this video. I love you. Academic Daddy, I will impregnate you academically. Please subscribe, like, and share. Okwa ini. Okwa